With a captive audience like this, I brought all my slides of my summer vacation and my cats and a new foal that one of our horses just had. Well, you and the universe is the theme of the conference, and so I wanted to share with you my fascination with astronomy ever since I can remember in childhood. I guess I was born interested in astronomy. I know a lot of people in this audience were as well. And that it is a driving force. It's something that you can't be without. The paper that I have written for the journal I will read from a little bit, but mostly, as I alluded to earlier, I brought along a huge pile of slides, and so I'm going to have to start ramming through them very shortly. But the question is, what is it that compels a certain small segment of the population to stand outside at night and watch the stars while the rest of the world's inhabitants never give more than a fleeting thought to anything beyond the earth? What is it that lures the astronomy zealot into the night again and again, knowing full well that he or she will soon be either uncomfortably cold or providing sustenance for the Canadian mosquito hordes? Why do they do it? Only a non-enthusiast would even think of asking the question. To the true amateur astronomer, us, a lengthy run of cloudy nights is like being deprived of a close companion, a friend whose presence is warm and comforting but stimulating and sometimes surprising. Standing under a sky spangled with stars and adorned by the silky ribbon of the Milky Way is intoxicating. We need our fix of starlight. We need to soar into the cosmic abyss, propelled by imagination, but fueled by the knowledge that those spears of light end their 100 or 1,000 or million-year journeys by entering our eyes and stimulating an image on the brain. But that's just the beginning. A purposeful glance at the stars by a real amateur astronomer triggers consideration about the origin of the light as it left those remote suns. Suns that light our planet from afar. Suns that might rule 100 planets. Suns that might live only 1 million years. Suns that pulsate with the predictability of a heartbeat. Suns that may have nurtured a planet of life and perhaps thought. Astronomy is not an easy hobby. To be good at it takes an inordinate amount of practice. To be hooked on it is to know that your life will never be empty, your brain never entirely at rest. For one thing, you'll always be dreaming about your next telescope. Let me give you Dickinson's awe factor. This is not a dental plan. This is the awe as in, ah. Any backyard astronomer knows how enjoyable it is to hear the oohs and ahs from people as they look through a telescope for the first time. It is even better to be able to utter the oohs and ahs yourself. With this in mind, here is the backyard astronomer's awe factor. A 1 to 10 scale of celestial exclamation. 1 on the scale is a detectable smile, a mild ripple of satisfaction or contentment. Factor 10 is speechless rapture, an overwhelming rush of awe and astonishment. Of course, we limit our discussion here to astronomical themes. Here are some examples for you, and you can develop your own list. This is just mine. 1 is any routine celestial view through binoculars or a telescope, seeing a faint meteor, reading a good astronomy book. 2, finding the planet Mercury, seeing sunspots, scanning the moon's surface with a telescope, discovering how clear things look in binoculars when they're mounted on a tripod. Seeing cloud belts on Jupiter. 3, viewing Saturn or the Orion Nebula through a telescope, even though you have seen them umpteen times before. The starry dome on a clear night in the country, Jupiter's red spot, colored double star. 4, beautiful sunset or sunrise, seeing a bright Earth satellite for the first time, a partial eclipse of the moon, a close conjunction of 2 planets or the moon and Venus, Earthshine in binoculars, finding the Andromeda Galaxy for the first time. 5, identifying Jupiter's moons in binoculars for the first time, a moderately bright comet in binoculars, seeing telescopic detail on Mars after trying for a long time. 6, recognizing your first constellation, seeing a bright meteor, a good telescopic view of a galaxy or a globular cluster, watching the shadow of one of Jupiter's moons crawl across the planet, seeing your first successful astrophoto. 7, first view of the moon through a telescope, first view of the Milky Way in binoculars, a total eclipse of the moon. 8, a rare all-sky multicolored auroral display, or the moment you begin to realize how immense the universe really is. 9, a bright comet, first view of Saturn's rings through a telescope, a bolide or fireball. 10, perfect view of a total eclipse of the sun, discovering a comet or a nova. Now, anybody can make such a list. That's mine. The final point, the final 10, one of those 2 I don't think I'm ever going to know. Rolf Meyer and Doug George can tell us about it, about the comet nova, or the comet discovery part of it. Seeing a total eclipse of the sun is something that most of us probably will be able to do at least once in our lifetimes. But I'll speak just a moment about the discovery of something significant, like comet or nova. Rolf Meyer and Doug George and others who have achieved what they have achieved and deserve our applause are the real amateur astronomers. In essence, unpaid professional astronomers, deliberately achieving results. Most of us are not amateur astronomers. I don't think if one is strict about the definitions. I regard myself more as a recreational astronomer, and I think this is a name that should come into wider use. Or, as I suggest in the title, Naturalists of the Night. So, with that introduction, let's go to the slides and take a little trip into our backyard observing situation. The trip begins with some aurora cooking up on the northern horizon, intermingled with the Big Dipper. This tree you'll see in a lot of these pictures. This is my favorite tree. One of those great white pines with the almost ballet arms hanging. It's just a great tree. You'll see more pictures of it. Very photogenic tree on my property. Well, I start with auroras because they're both the simplest thing to see and the simplest thing to photograph, and yet the only way you do either is to be outside and looking. And that, more than anything, is the key to amateur astronomy or recreational astronomy. To do it as often as you can, whatever situation permits. Those who are fortunate enough, like myself, either through accident or design, lived in the country where you can see 6 magnitude stars from your backyard, naturally have an advantage. But getting out there and looking, there's always surprises to be seen, and auroras are certainly among them.
What film is this used on?
There's a variety of films used here, but the main ones, well, there's 3 that I've used in these aurora photos. Fujichrome 1600D, Scotch Chrome 400 pushed to 800 usually, and Ektar 1000 print film. This is an aurora from 1 month ago. We have had some decent ones recently. This is also one from just a couple of days different from the other ones, the first blue aurora I've ever seen.
This one was from the equinox aurora this year on March 2021. There's my favorite tree again. Now the source of this is, of course, the sun. This is a terrific sunspot photo by John Hicks of Keswick, and this was taken with an 8-inch celestron, and John has been working for years to work up to this kind of resolution. He also took this picture showing the flares and prominences that release the solar material, the protons and electrons that get interwoven into Earth's magnetic field, as shown in this illustration by space artist Don Davis, which shows the nighttime side of the Earth and the auroral oval here. Here's North America with the nighttime lights, the natural gas vents from the wells in Alaska, and some of the wells in Venezuela. He doesn't have, as Lydia Dotto mentioned, because this was drawn before they were starting to burn down the rainforest. That would show up as well from space. So this is an attempt for an accurate nighttime view. The auroral oval is centered on the Earth's north magnetic pole, another one on the south magnetic pole, and expands and contracts depending on the intensity of the particles wound up in the Earth's magnetic field. And the interaction with them and the gases in the upper atmosphere in a sort of neon tube effect produces the auroras. Well, normally from where we are in southern Canada, we're looking north to see the aurora. And the next sequence of 3 pictures spans the auroral oval from over here. The first picture is this section. The second picture is this section. And the third picture is this section from the ground. Okay, so here's the edge of it here. And you can see it arching up. Here's the middle section. And now the right section ending here. The auroral oval was particularly evident as we're looking north to it and to its vertical extension. This is one of the most outstanding aurora pictures I've ever seen. This was taken from Yellowknife by a correspondent of mine. Just a truly spectacular picture. This is back to the backyard shots. This was the equinox this year aurora. And this was the great red all-sky aurora of March 12-13, 1989, perhaps the best aurora I've ever seen. It was so bright that I could read the settings on my camera taking it. You can see that the snow on the ground is illuminated purple by the aurora. This was the peak of that auroral display. Just astonishing color, the red color being very, very evident to the eye. This is a coronal aurora, and this one occurred in September of last year, of incredible brightness because this is the gibbous moon, and the aurora was overpowering it. This was taken by Marty McConnell of the Kingston Center. Probably the best example I've ever seen of coronal aurora with the moon in the picture. Just astonishing. That was taken from, I think, near the city limits of Kingston. This was taken by Toronto Centre member Darnley Wright. I think the best example I've ever seen of actually looking up into the auroral curtains. You can see the curtain effect very clearly in this image. This is what I call the warp speed biker. This is a coronal aurora from the equinox aurora of this year. Here's his helmet. There's his beak there. His arms, the handlebars, his collar, his back. And you can't see the wheels of the bike because they're going too fast. The intensity of the shapes, there was also an eagle picture that came out of this too. It's just remarkable. Halley's Comet. And another shot of Halley showing a very faint, about 10-degree tail. I put this in because this is essentially how it appeared from Canada. And its best period after everybody stopped looking at it was the end of April 1986. After the hype was all over, that's when it, of course, when it shone. Another Halley image over here. Comet Kohoutek was in discussion around the time that Comet Austin was visible. Comet Austin gave an even worse show than Comet Kohoutek. Here's Comet Austin. And if you use averted vision, you can see the tail extending up to about here with a kink in it. It's pretty tricky to see. This is the Andromeda Galaxy. Here's a color-corrected image. I don't think the tail's any easier to see, though. And that was about it. That was the best, at least the best shot that I got. Now, this isn't as astonishing as it first seems, that the predictions could be so far off. There's a huge range to what comets can do, and it's certainly difficult to predict what they're going to do. But there was suggestions that Comet Austin was going to be something like, or another incarnation of Comet West. This was Comet West, taken with a similar kind of lens to the previous picture of Comet Austin. So there was no similarity whatsoever, but that is the fascination of comets, in that they are so unpredictable, and you got to be out there looking for them. And to see one like this, which I never did because of bad weather, is a sight of a lifetime. Comet West was visible in 1976. This shows how bright it is. I didn't take this picture, as I mentioned. I got clouded out, but you can see there's nothing else in the sky, virtually, except for the comet, and even taken from right in the middle of a village. Another shot of Comet Austin within 24 hours of it being closest to the Earth. This is Delphinus here. And of course, that's the comet with the vaguest hint of the tail above it, but major disappointment. Another comet from last year, which has a connection to us, Comet Levy-Rudenko. David Levy, of course, a Canadian, a member of our society. At the time this picture was taken, the comet was right there. Right there. With a rather overexposed moon in the picture. But this is the kind of challenge that I don't think has any value other than the fact that you go out, do it, and see the results and say, I photographed the comet right beside the moon. And these are the little joys, the kind of thing that make you part of the universe. I know that sounds crummy, but you do get this feeling. You do, more you know and appreciate and partake in personal exploration, the more meaningful it becomes and the more edifying the exercise is for you. Well, we have a new comet in the skies, again not far from the Andromeda Galaxy. This is Alpheratz, in the connecting star of Andromeda and Pegasus. And on Tuesday night of this week, I took this picture, and if you can see it, there's a little fuzz right there. I mean, amateur astronomers are connoisseurs of little baby fuzzes. And here's one. This is Comet Levy, David Levy's sixth comet. I saw it in 10 by 50 binoculars with no problem under a good sky. And it's still within the field of view of Alpha RASC. So you can see it. I was going to say tonight, but I don't. Well, if it clears, but prospects are not too good. This is typical amateur astronomy land. Smudges. So many things that we pursue are smudges, which to the non-enthusiast are probably better than seeing nothing at all, because they have an image in their mind about what astronomical objects look like from photographs, and then when presented with something like this, invariably say, is that it? Well, of course, that's it in a visual sense, but in a cerebral sense, that isn't it at all. Is it a dying star? Is it a city of 100 billion stars whose light left that object farther ago, longer ago than the time when the dinosaurs ruled the Earth? And that very light, that same light that's been on its way for 100 billion years, is the light that's entering your eye and stimulating the image in your mind. And those kinds of thoughts are never far away from the true amateur astronomer's perception when he or she is out under the stars. More fuzzes. Can you pick anything out here? Typical circumstance in the initial stages and even in the later stages is poking around, having fun, finding these things, and discovering what each little fuzz looks like. Now, this is sounding like something that is really obscure, but it isn't. You know it isn't. Seeing M81 and M82 in binoculars for the first time is not only an accomplishment, it's right there on the in the middle of the awe factor list. You feel it. And that's what it's all about, the feeling that comes from seeing so many different representations of nature on such a vast scale. These are the objects that were those little blips in the previous picture. Or thinking about it this way, M66 and 65 are sort of the same size as the Andromeda Galaxy and the Milky Way Galaxy, and that's about the way they would appear from 40 million light years. Or we would appear that way if we, to someone on a planet of a star in those galaxies. Or something a little bit simpler, easier to do, and just as interesting. Tracking or identifying objects, of course the crescent moon, Venus, Mars, and Saturn in this particular view, but just the changing panorama of the sky in the morning and the evening especially is something that amateur astronomers do just out of habit. Here's a conjunction. This was right on the horizon. It was cloudy up until this little break in the clouds when there's trees right here. Jupiter and a couple of its moons. And this was a conjunction of Jupiter and the moon just a couple of weeks ago. Here's Jupiter again in a different guise. Jupiter, that bright object in the middle, M35. Here, we saw some pictures last night of this same situation. And then there's these IC objects that I've forgotten. If Paul's here, he could tell me what the names of these two are. Yeah, I can't take credit for this great shot. This is beautiful occultation of Jupiter by the moon, of course, the unilluminated side of the moon. And of course, nobody's taking credit for this one either. But I put this in because we know so much more about the universe than we did a couple of generations ago, and in some ways this has changed the way amateur astronomy proceeds. I think that the recreational component of amateur astronomy has grown enormously, and that is the growth area for the future. There's always going to be the smaller number who pursue it in a more rigorous fashion, and that doesn't mean they will accomplish anything less. They'll accomplish more in the future, and I'll get on to the predictions of what ways they will do that. But faced with such images as this, when you look at Jupiter in a telescope and see much less, does that diminish it in any way? No, because you're seeing the real-time image of Jupiter. Here's a drawing from of my own from about 25 years ago, showing what a 3-inch refractor will reveal, including the shadow of Ganymede here. And those kinds of little sketches over the years are something that are really inspiring to look back on. This is I put in to show where the pinnacle of this particular area is. This is the drawings of Jupiter by Miyazaki, who is probably the greatest amateur planetary observer at work right now. These drawings of Jupiter were made with an 8-inch Newtonian. Is he imagining this stuff? Well, no, it's Voyager quality stuff that comes from a trained eye and a superb telescope. Here's something that is much more local. This is from the Hamilton Center. These are drawings made by a group of Hamilton Center members who drew Jupiter and the major features they saw as the planet rotated and made these strip maps, just out of a sort of little group project, something that brought a lot of people who were observing, but brought them together with a common project, and the results are obvious here. Very successful. Well, Mars is coming to an opposition this fall, and it'll be the last good opposition of the 20th century for Canadian observers. An opportunity to, for me to extend the observing of Mars that began even almost 10 years before this drawing was made, and the updating of the surface features of Mars, which change all the time due to wind propagation around the planet and transport of dust. And these are the sort of amateur maps that are being made these days that come out as a composite of many amateur astronomer observations. Notice the canals of Mars still shown here. These things are absolutely real. Once I started using a 7-inch refractor to observe Mars, I started seeing them regularly. And all I'm seeing is the same effect that Percival Lowell saw, in that Mars just happens to be at the right distance from Earth, that the atmosphere of Earth allows a certain resolution, that once you get up around a 6 or 7-inch telescope, you begin to reach the stage where you're seeing almost atmospheric limited resolution. And the effect that the eye has on the particular surface features of Mars is the connecting of that detail into linear features. And you really do see them once you have observed Mars for a long time and are practiced at examining the planet in more detail. Well, let's move on. We've moved on quite a way here to the Magellanic Clouds, viewing back toward the Milky Way in an illustration from one of my books. Here is our position in our galaxy. One more major spiral arm past us and several loops inside. And our viewpoint here, when we see the Milky Way in the sky, we're seeing the part of the galaxy around us. Here also is our position with the galaxy face on in a sort of a stylized way. The spiral arms, I'm sure, are not as symmetrical as they appear here, but nonetheless, that's a good basic picture. Here's an all-sky picture of the Milky Way from Mount Graham, taken when they were selecting that site in Arizona, 9,000-foot mountain for astronomy, showing from the galactic core almost 180 degrees, and you can see the diminishment of the width of the galaxy throughout that length. Again, another galaxy showing the situation. Our position here, latest figure I think is about 24,000 light years, keeps shrinking. We don't keep moving in. The galaxy is smaller in our mind. And viewing toward the hub of the galaxy has never probably been shown better than in this picture, or a couple like it. This was taken by Jerry Rodriguez, who is a sports photographer for the Philadelphia Inquirer, and he has about $30,000 worth of Nikon equipment, and he got interested in astronomy, and this is some of the results that he's had. And here's the central hub of the galaxy, and of course, the spiral arms and the dark areas being the intervening dust matter. Back to my backyard. Here is the constellation Scorpius, and for those of you from out west, you've never seen this part of it here, at least from out west, the complete fishhook around to the end of the tail of Scorpius, M7, M6, the nucleus of the galaxy, Lagoon Nebula, and the McDonald Service Center, which was just built. I had an absolutely perfect southern horizon until 3 months ago. That's 10 kilometers away. That's one service center on the 401. Nonetheless, I still have reasonably good skies from my backyard. Here's M7 again at the bottom. Can you see this red dot? No. Okay. I will put it away. So I keep shining it on the screen and wondering if people are seeing it. M7, M6, the Lagoon Nebula, and the Trifid Nebula, Sagittarius star cloud, and so on, and the nucleus of the galaxy. From Canada, we could still get a pretty good shot at the central region, at least from this part of Canada. This was taken just this month, or this couple of weeks ago, in the new moon. No, actually, it was 1 week ago. Here's the hook of Sagittarius here. And these are various nebulas below M7. There, here, and this one, which is about, I think that's about 5 degrees from the horizon. Oh, McDonald Service Center again. And I've never got this one before, at least in any detail. So we can, again, this was just a personal challenge to capture something that far south. And I don't think it means anything other than just go out and try it and get a pretty picture. Okay, let me share with you a real high for me, which was a double-barreled high. The Jet Propulsion Laboratory during the Neptune encounter at the Press Center. I was there for Equinox magazine for a feature article. Here's the mission control for the Voyager 2. And the palatial setting for the press. And the gorgeous photos of Neptune sent back by Voyager 2. Now, when these pictures came back, that one, and it was around the time that we were getting the incredible Triton pictures, this one, showing details just a couple of kilometers resolution on an object that had never been more than a dot in telescopes from Earth up to this very day that these pictures were taken. Well, the night after that, with one of the a friend from who was at JPL from one of the NASA centers, and I went up to Mount Pinos, which is a 9,000-foot mountain about 100 miles north of Los Angeles. Well, what we discovered when we got up there, right on the summit of this mountain, was that by pure luck, conditions were perfect. You can tell by this sunset with the blue, almost black sky descending rapidly on the setting sun, that we're in for a hot night. Hot in terms of what we're going to be able to see. Now, this shows why. This gunk down here is Los Angeles. And this layer here is an inversion layer which effectively blocked the light of Los Angeles so that you could see the Milky Way come practically right down into it. The sky was absolutely black. The Milky Way, brighter than I've ever seen it. It's the rapture I was talking about. I couldn't believe how fabulous it was, and fortunately had my camera in a little portable equatorial mount. And the Milky Way was truly incredible. This is, I think, the best shot of the series. The Milky Way is astoundingly bright and contrasted to the eye. It was the first time I'd ever seen this section of the Milky Way over here clearly naked eye. The section around the dark horse. Back to Toronto. This picture was taken when I lived in Toronto decades ago. And of course, the situation has gotten worse since. Light pollution is a very serious problem to both professional and amateur astronomers, and something that is going to have to be tackled sooner or later, because this was the situation in 1979. Here's Toronto. This is an Air Force. This is a negative picture. This is Lake Erie here, Lake Ontario. And this is a photo from a U.S. Air Force satellite that specializes in nighttime photography. And it showed the village of 300 that I live near, Yarker, Ontario, is shown on this. You can see it from 200 miles up. And of course, big cities, it's just wall-to-wall light. Of course, the problem is ill-thought-out lighting. These lights were intended to light this sidewalk, and you can see they don't even do it. Even this side of the sidewalk isn't lit, but it does a terrific job on the second-story windows. Billboard near me, where of course most of the light is going to light up particles of air rather than the information. This photograph was taken in San Diego. All the lights in San Diego have now been converted to shielded and low-pressure sodium. And the same in Tucson, all the public lights anyway. And the city is amazingly changed because of this. So much so that some of the old lights that are still left, take a look at this one, the residents have got a ladder, climbed up this thing, and painted the side facing their house black. Can you see that? And that's because when this changeover occurred, the city and environmentalists told people about the problem of light pollution, and that the solution would cost less than the problem, and there was a great deal of response to it, largely positive, by far the majority was positive. And as I was driving around, I saw that this couldn't have been done by anybody else other than the residents of this house, who decided to take action themselves. So the attitude can be changed. And ways to do that, there are avenues for amateur astronomers. Randy Atwood's Astronomy Toronto was certainly a terrific example, and a great effort put into it over the years that it was on cable television in Toronto, offering opportunities for people to look through telescopes, and just one of many, many different ways to accomplish the same thing. Now we're going to move on to amateur astronomer instrumentation, and I'm going to rip through this because I'm running out of time here. And we can go to the first one of this section. I'd like to acknowledge the slides of Alan Dyer, quite a number of them in here, including this one. Amateur astronomers talking telescopes. What else? Amateur astronomers looking through telescopes. What it's all about. Alone or together under great skies. The only dark cloud on the horizon is the deterioration of those skies and the fact that we have to go farther and farther to get them, or that those of us who are in them feel encroached upon and are, in fact, being so all the time. Another great Alan Dyer picture here of amateur astronomers freezing. One interesting thing that has happened in the last decade, and I think it's of fundamental importance in broadening the hobby, is that for the first time ever, 3 major classes of telescopes with largely different capabilities and complementary capabilities are now widely available in different designs by different manufacturers, but they all effectively compete with each other. This has never happened before. There has never been a choice of instrumentation across such a wide spectrum of capabilities. And I think that this has broadened the hobby in an important way that is never mentioned. But the fact that people can select, and when there's groups of telescopes around, you've got so many different capabilities of those instruments that can complement each other and allow you to have better views of the entire range of celestial phenomena than ever before. And this has meant the spectrum of amateur astronomy has broadened. And it's richer now than it's ever been before. The 3 types are the Schmidt-Cassegrain on the left, the refractor in the middle, and the Newtonian telescope on the right. The old refractors, long, somewhat cumbersome, crippled by chromatic aberration in larger apertures, difficult to mount. They went out of style in the 50s. The new refractors, apochromatic with far better color correction, shorter tubes, excellent optical capabilities, high resolution, plus wide field of view. They become a viable force in the amateur astronomer's arsenal. The 1950s style Newtonian telescope on the plumber's nightmare. The 60s style Newtonian telescope on the heavy equatorial mount, the hernia model. And the 80s style and maybe the next century style and the 90s style Newtonian. Light, portable, big aperture, and easy to use. And of course the Schmidt-Cassegrain, the ultimate in portability, the most all-round and versatile telescope of all, that has introduced so many people to amateur astronomy. So all of those combined have given the subject a new breadth and richness that it's never had before. Okay, let's have the lights on, please. For my final comments, what will a well-equipped amateur astronomer be using in the 21st century, or the year 2090, when the RASC turns 200? Forecasting trends is always tricky, but I'll foolishly plunge in by making a few, perhaps outrageous predictions. Eventually, today's frontier technology will become available to amateur astronomers. Current frontier areas include motorized, smoothly tracking altazimuth mounts, active optics that compensate in real time for seeing variations, variable index lenses that correct for aberrations inside the lens so that one lens does the job of several, and so-called rubber mirrors that are just a few centimeters thick but are backed by many sensors and actuators that might
that can, through a computer, constantly retain perfect optical figure. With these innovations, extremely fast f2 or even f1 primary mirrors or lenses might be possible in amateur scopes. A 10-inch refractor might be as compact as today's 8-inch Cassegrains. The focal ratio at the eyepiece could be f5 or f10 or whatever you choose, depending on the corrector-Barlow combinations inserted in front of the eyepiece. A 24-inch Cassegrain type reflector with an f1.5 primary mirror would be readily portable. The system might operate at f5 through the use of exotic corrector-Barlow lenses with seeing compensation to boot so that you could use the full aperture. All telescopes will be on altazimuth mounts driven in both axes. The operator will inform the telescope of its exact location if it's not the usual observing site, then point the instrument at a known star. Perfect tracking will begin immediately. Charts and tables will be stored in a light slab about the size of a cafeteria tray that will show any part of the sky at any scale to any magnitude, including planets, asteroids, known comets, and magnitudes for everything, including variable stars. Information tabulation for any object that you touch on the light slab will appear at request. Also on request, the telescope will point to any object touched on request. The light slab will also show that what the telescope is looking at, field of view. It will specifically show it. It will appear on the light slab because CCD type sensor will flip into the light path of the telescope when the eye is taken away. In astrophotography, film will have given way to electronic imaging for all astronomical applications by 2090, almost certainly long before that. A 10-inch backyard telescope will reveal what the 200-inch Mount Palomar telescope recorded soon after it was built. Images will be digitally recorded for viewing at leisure later on your own TV set, or in that case, a wall slab. And available at leisure for image enhancement. Extremely sophisticated light pollution rejection electronics will mean astrophotography will be possible from the city, and God knows what the light pollution situation will be then. Maybe it'll be better. Those amateur astronomers who choose to do so will be able to monitor huge numbers of variable stars to 0.01 magnitude, conduct 18th magnitude supernova searches in distant galaxies by overlaying their own images electronically, and seek extremely faint comets in the same way. Others may choose to simply watch the light slab display the universe as it passes by in random axes motions on the telescope. Well away from the Milky Way, the images of even an 8 or a 10-inch telescope would contain as many galaxies as stars. So, to conclude, I offer the following quote from an issue of the Ottawa newsletter Astronotes from a few years ago. I didn't record who the author was, and if he or she is here, I'd like to know who it is. But this was a concluding remark in an article in Astronauts. The objective is to explore strange new phenomena, to seek out new celestial objects and new nebulosities, to boldly look where no human has looked before, and mainly to have fun. And do I have time for 5 more minutes, or are we pushing it? Thank you. Okay, roll the tape and the slides. This is a backyard from Eastern Ontario collection.
I think there's two approaches to it. One which doesn't work very well, and that's becoming belligerent about it. But I think there is an approach that appeals to the new environmental awareness that people people have and are properly achieving. I think we're all sort of in this category. And I think we can play a role in expressing how the heritage of the night sky is going to be deprived to our children. Within a couple of generations, it'll be so difficult to see a proper night sky that most people won't see it without making a great deal of effort. That kind of message just isn't realized, but it's true. That the last thing that kids see in the sky when they're born into this world today is the stars, and it used to be the first. And the other thing is, just as amateur astronomers, you can start with your neighbors, view through the telescope, and a mention of the light situation, and they can only realize it when they're there standing at the telescope, seeing their porch light shining on the scope, that it just saying it doesn't really seem to work. But what I'm trying to do is use my newspaper column in the Toronto Star and some of the other avenues that I have to express the problem, and that it can be corrected at more efficiency and less cost, which I think is the other chief thing. But it's going to be a long battle, because there's so many other environmental frontiers. But it's one we've got to fight.
Ontario Hydro has just announced a plan to assist communities with new lighting, roof coating, the whole thing, an economic program. So I think the best thing is to go right to your municipality.
Yes. This is a key thing. One of the chief things that you should do is find out who in the municipality has any kind of a interest. What I've found is that the engineers or engineering-oriented people seem to understand the words
that you say about the lighting problems better and more easily and seem to hook into the idea. It's a new idea for most people. And that is certainly the most effective thing, is if you can make a personal contact with a municipal official who has some influence in these sorts of decisions, then you can make headway. And since Hydro is offering this, I know, and also the lighting in Toronto is also being reviewed by a committee now. It's been set up by Howard Levine, who's a counselor who in my last correspondence with him referred me to the light pollution article in the current issue of Sky Telescope. Said, have you seen it yet? So here's someone who's fully aware of the problem, and it's beginning to happen. And I think that's certainly a very crucial area.
I might add that when this General Assembly is over, the Ottawa Centre is going to pursue the problem of light pollution in this area. We have formed a committee which unfortunately has had not much time because of the organization of the General Assembly, but will devote the rest of the year to the problem of light pollution, as particularly as it affects our observing site west of Ottawa.
Point two, I remember they started to put lights up and neighbors walking along the street. The lights, they cost about $2,000 a standard, and it's the policy of Ottawa to put lights on every street. So when you see your taxes going up, it usually goes for lights, and you don't have to ask for them. Somebody on your street will raise a priority. They don't even have a choice in what type of light you're going to get. And that is usually coach lights, which are actually, I think, less efficient than the Cobra lights, but they're perhaps more pleasing to the eye, at least during the daytime.
In San Diego, they actually took lights out when they went around putting the new type of shielded lights in low pressure sodium. And the policy was for the people who complained, they would leave the lights in, but the 4 houses closest to the light would be billed on the tax bill for the light. So less than half of 1% of the people who complained actually accepted that offer.
So we have maybe 2 more questions, one at each microphone.
Oh, no more.